f of x is x cubed. We want to compress it horizontally by a factor of 2. Now, what we know is that to compress it horizontally, we want to multiply by that factor. So we now have f of 2x equals 2x cubed. We want to reflect it in the x-axis, so we're making it upside down. So negative f of 2x, which is negative 2x cubed. And then we want to shift it downwards by 3 units. So negative f of 2x minus 3 equals negative 2x cubed minus 3. And just to expand out the right-hand side, that's going to be negative 8x cubed minus 3. And so the transformed function, which I'm going to call g of x, that is negative f of 2x minus 3, or in other words, g of x is equal to negative 8x cubed minus 3. Now, I want to point something out here. Here's our original function. If we apply these transformations, here is the new function. There's something really important to point out here, though. We could reach this same transformation by doing something different. Instead of compressing it by a factor of 2, flipping it and shifting it down, what we could do is we could scale it vertically, not horizontally, vertically by a factor of negative 8. That will flip it and stretch it and then shift it upside down. So have a look at this. As I said, we could go negative 8 f of x, that's our vertical shift, and then we move it down by 3. And what you can see is that that's exactly the same as the other transformed function we had. And what this is telling us is we can get to the second function through more than one combination of transformations. But in either case, what we are graphing is y equals negative 8x cubed minus 3. These are all the same function. They are what you get when you take this function and you apply this combination of transformations, or you apply this combination of transformations. They're equivalent in this situation.